Hi students, I am Raghavan, chemistry faculty from All Force College. I am inviting you all for the All Force chemistry e-learning sessions, that is session number 26th. See, in the last 25th session, that is in the last session, so we were discussing about azimuthal quantum number. Okay, so that is quantum numbers under this quantum numbers. Under this quantum numbers, we completed principal quantum number and we are doing azimuthal quantum number. Azimuthal quantum number. We are doing this. Azimuthal quantum number. Okay. Azimuthal quantum number was explained by Sommerfeld scientist. Azimuthal quantum number was explained by Sommerfeld scientist. Explained by Sommerfeld. Yes. So Sommerfeld explained azimuthal quantum number. So why he explained azimuthal quantum number? By introducing elliptical orbits. Okay, Sommerfeld introduced elliptical orbits. He introduced elliptical orbits. He introduced elliptical orbits. Okay, fine. So to explain angular momentum, okay, another point, to explain angular momentum. To explain angular momentum. Yes, once again, the complete sentence. To explain angular momentum of electrons, Sommerfeld introduced elliptical orbits. To explain angular momentum of the electron, rather we can say to explain fine spectrum, Sommerfeld introduced elliptical orbits. Sommerfeld introduced elliptical orbits to explain angular momentum. Okay, to explain angular momentum. Fine. So, therefore, azimuthal quantum number was given by the symbol L. Azimuthal quantum number is denoted by L. Okay, azimuthal quantum number denoted by L, and the values of L depends upon principal quantum number values, that is n values. Depends upon n values. Depends upon n values, and L values always equal to n minus 1 values. Always equal to n minus 1 values. Okay, L values represents what? L is equals to n minus 1 values. That means L values starts from, it can be less, it should be less than n values. Okay, it is L is equals to n minus 1. That means it starts from 0, 1, 2, 3 and so on. These L values represents subshells. These values represents subshells, or we can say suborbits, or we can say sub-energy level, because orbit, suborbit, shell, subshell, energy level, sub-energy level. Okay, these values L is equals to 0, 1, 2, 3. These values represents various subshells. Okay, various subshells. Okay, once again, azimuthal quantum number was explained by Sommerfeld by introducing elliptical orbits. He explained angular momentum of the electron. Therefore, azimuthal quantum number is also called angular momentum quantum number. Okay, angular momentum quantum number, and it explains existence of subshells. Therefore, it is also called, that means angular, that is azimuthal quantum number is also called subsidiary quantum number. It is also called subsidiary quantum number, right? What are these values? L is equals to 0, 1, 2, 3. These values represents the various subshells. And another point, okay, this represents various subshells. Now, L is equals to 0. when L is equals to 0, okay, that is L value, this is L value, say it is first column, then designation given to that, designation of subshell, L is equals to 0, that is L value, this represents what? Subshell, L value means subshell, this represents subshell, okay, subshell, and designation of that subshell, L is equals to, see for example, L is equals to 0. What is the designation given to that subshell? L is equals to 0, that is S subshell, S subshell. When L is equals to 1, that is P subshell. L is equals to 2, that is D subshell. L is equals to 3, that is F subshell. F subshell, okay. So that is based on the L values, the designations of the various subshells are noted like this, okay. So these values, that is these, instead of using the original values of the subshells, okay, now we are identifying the various subshells with S, P, D, F letters. These letters are selected based on the spectral diagram, that is spectral lines, that already we explained under Sommerfeld's model, okay. So that is azimuthal quantum number represents subshell, azimuthal quantum number represents subshell. And finally coming to this, azimuthal quantum number signifies to explain, azimuthal quantum number signifies to explain existing of subshell and their shape, existing of subshell and their shape, okay. Let us finish another column, okay, that is azimuthal quantum number signifies to explain existing of subshell. What subshells are existed? Yes, 0, 1, 2, 3, that means S, P, D, F, and their shape. The shape of the S subshell is always, remember, spherical, and L is, that is L is equals to 1, that is P subshell. So P orbital is always dumbbell, okay, and D subshell is double dumbbell, and F subshell is always, F orbital is always complex structure. In some other reference books it is given 4-fold dumbbell, okay, you can also note that point, 4-fold dumbbell, but it is complex structure. So the 3-dimensional diagrams we cannot draw on board, okay. That is spherical, dumbbell shape, it is double dumbbell, and it is complex structure. So this is the information, outline information is available from the azimuthal quantum number. Now coming to the point, azimuthal quantum number, that is azimuthal quantum number, it represents existence of elliptical suborbits, that means subshells, suborbit means subshells, existence of elliptical suborbits in addition to circular suborbits, okay. Azimuthal quantum number explains existence of elliptical suborbits in addition to the circular suborbits in a given energy level, means orbit, in a given energy level, means in an orbit, okay. So another point here, only let us underline one more point here, that is how many circular and how many elliptical suborbits are existed. Next point, total number of suborbits, that means subshells, total number of suborbits in a shell is equal to n value, okay. Total number of suborbits means subshells in a given energy level is equal to n value. That is one point, okay. We can also add another point, maximum how many circular and how many elliptical suborbits are existed? So maximum only one circular suborbit maximum only one circular suborbit existed in any given energy level. Circular suborbit is existed in an orbit. Okay, in any orbit maximum only one circular suborbit is existed, okay, and the remaining rest are elliptical suborbits. Okay, once again let us go through this. Azimuthal quantum number explains existence of elliptical suborbits in addition to the, remember, in addition to, it's not compulsory, in addition to circular suborbits. Okay, that means circular suborbit must be there in the orbit. In addition to the circular suborbit, elliptical suborbits may exist. Okay, that should understand. Okay, in a given energy level. Okay, after this, next, in a given energy level, that means in a shell, that means in an orbit, maximum total number of suborbits, how many they are existed? That is the total number of, maximum number of suborbits means subshells in a shell equal to n value. For example, in second orbit, how many suborbits, how many subshells are existed? 2, because n is equals to 2. Okay. In third orbit, how many suborbits are existed? 3. In first orbit, only 1. Okay, like that. Next, maximum how many circular and how many elliptical suborbits are existed in the given energy level? Yes, maximum only one circular suborbit is existed in an orbit. That means in any given orbit, in any given energy level, maximum only one circular suborbit and the remaining are elliptical suborbits. Okay, so based on these points, let us exercise examples. Okay. Right, n is equals to 1, that is first orbit. In this first orbit, now the total number of suborbits in first orbit, n is equals to 1. First orbit, n is equals to 1, that is K shell. In this first orbit, maximum how many suborbits are existed? Number of subshells. Total how many subshells are existed? That is equal to n. Remember that. Okay. Total number of subshells in the orbit is equals to n. Okay. That is second column. Next, third column. L values. What are the possible L values? Okay. Then based on the L values we can say now number of circular suborbits and number of elliptical suborbits. Number of circular how many and number of elliptical are how many, we have to identify that. Okay, so we should fill this data. Now n is equals to 1, that is orbit. That means in an orbit or in a shell, n is equals to 1, that is first orbit, that is K shell. In first orbit, total how many subshells are possible? How many subshells are existed? In first orbit, total how many subshells are existed? Just now we had the discussion that means the maximum number of subshells in a given orbit is equal to n. That is in first orbit, n is equals to 1. So therefore, only one subshell is existed. What is the value of L? That is 0. Okay, what is the designation given to that subshell? L is equals to 0. L is equals to 0, that we understood. That is S subshell. Okay, you got it. Okay, that means when it is only one subshell, is it a circular or elliptical subshell? That is nothing but it is a circular subshell. Okay, no elliptical suborbits are existed in that first orbit. That is the data we filled in the first orbit. Okay, next let us take up in second orbit. n is equals to 2 in second orbit. N is equals to 2. Okay. So we are going slowly, try to understand the clear concept. Okay. In second orbit, that is nothing but L shell. Okay. K shell is completed, now L shell. In second orbit, maximum how many subshells are existed? Maximum number of subshells in the orbit is equal to n value. So that means n is equals to 2. That means we have 2 subshells are existed in the second orbit. 2 subshells are existed in the second orbit. So these 2 subshells, okay, what are the possible L values for them? The possible L values are 0 and 1. 0 represents S subshell and 1 represents P subshell. Okay, and out of them, one is circular. Yes, total we have 2 suborbits. Okay, one is the circular suborbit, the second one is elliptical suborbit. Circular is 1 and elliptical is also 1. Okay, that is the data in second orbit. Okay, now coming to the third orbit, n is equals to 3. That is nothing but M shell. Okay, in third orbit, what are the possible subshell values, L values? Okay, so that is total number of how many subshells are available. So n is equals to 3, therefore we have 3 subshells, that is 3 suborbits. Okay, what are these 3 suborbits, L values? What are the possible L values? 0, 1 and 2. The possible L values are 3, 0, 1 and 2. What does L is equals to 0 represents? S subshell 1, P subshell 2, that is D subshell. Okay, L is equals to 0, 1, 2, S, P, D subshells, and number of circular and elliptical suborbits. So out of these 3, one is circular suborbit and the second one is, that is remaining 2 are elliptical suborbits. Okay, next n is equals to 4. N is equals to 4. When n is equals to 4, that is nothing but n shell, n, fourth orbit, n shell, k shell, L, K, L, M, N shells. Okay, so in fourth orbit, how many subshells are existed total? So total 4 subshells are existed. What are the values of 4 subshells, L values? That is 0, 1, 2 and 3. The 4 subshell values, that is azimuthal quantum number values. L values are 4, 0, 1, 2, 3. It should be less than n. Okay, remember that. Now what are the designations given to them? It is S subshell, it is P subshell, L is equals to 2, that is D subshell, L is equals to 3, that is F subshell. So the 4 subshells are existed. Out of the 4, only one is circular suborbit, that is circular suborbit, and the remaining 3 are elliptical suborbits. Remaining 3 are elliptical suborbits. So these are the values based on principal quantum number and azimuthal quantum numbers values and number of circular and elliptical suborbits, that means subshells. Okay, so it is connected to orbit and suborbits, means subshells, based on principal quantum number and azimuthal quantum number. The data is very important for all the examinations. Okay, so this data mainly useful for your only objective examinations. Okay, right. So the data is very, very important. You have to copy, and the better thing is you can understand very easily. So it is first orbit, second orbit, third orbit, fourth orbit. In first orbit, maximum how many subshells are existed? So only one subshell is existed. So what is the L value of that subshell? It is 0. That represents what? That is nothing but S subshell. Okay, that is nothing but S subshell. Yes. When it is S subshell in the first orbit, we observed, is it a circular or elliptical suborbit? It is a circular suborbit. No elliptical suborbits in the first energy level. In the second energy level, that is L shell, maximum how many subshells are existed? Maximum 2 subshells are existed. Okay, so what are the designations given to them? 2 subshells, that is L values 0 and 1. Designations of that subshells, S and P subshells are there. Okay, and out of these 2, How many circular? So that is S is always circular suborbit, one circular suborbit, and L is equals to 1. Okay, that is elliptical suborbit. Next, in third orbit, in the third energy level, M shell, how many subshells are existed total? Total 3 subshells are existed, because it is equal to n value. Okay, it is equal to n value. So 3 subshells are existed. Their L values, possible L values for them, 0, 1 and 2. These are the possible L values. What are the designations given to them? When L is equals to 0, S, and 1 is P and 2 is D. Okay, these are the designations of the various subshells, and the number of circular and elliptical suborbits among them. Only one is circular, the remaining 2 are elliptical suborbits. Okay, got it? Now, when n is equals to 4, that is 4th energy level, that means 4th energy level means n shell, K, L, M, n shell, okay, 4th orbit. So the total number of subshells existed in this 4th orbit are 4. So 4 subshells are existed. So what are the 4 subshell values? So subshell means L, values 0, 1, 2, 3. These are the subshell values. What are the designations given to those subshells? S, P, D, F subshells. These are the subshell values. Then out of them, how many circular and how many elliptical? So only one is circular and the remaining 3 are elliptical suborbits. Okay, so this is azimuthal quantum number is completed. Okay, now coming to the magnetic quantum number. Magnetic quantum number, right? Magnetic quantum number was explained by Landé, scientist. Okay, magnetic quantum number. The third one is magnetic quantum number. Magnetic quantum number. Magnetic quantum number was explained by the scientist Landé. Landé discovered magnetic quantum number to explain. Landé discovered magnetic quantum number. He discovered magnetic quantum number. Okay. To explain Zeeman and Stark effects. Zeeman and Stark effects. To explain Zeeman effect. Zeeman effect, and the second is Stark effect. Yes, what are these Zeeman and Stark effects? Yes, let us see. See, for example, n is equals to 4, that is 4th orbit. In 4th orbit, what are the possible, that is 4th orbit, what are the possible L values? This 4th orbit has the number of subshells 4. We know that. Number of subshells 4. What are the 4 subshells we have? What are the values of 4 subshells? So, this is shell. That is K, L, M, N shell. Okay. In this N shell, the possible subshell values are L values. L is equals to 0, L is equals to 1, L is equals to 2, L is equals to 3. Okay, this is principal quantum number. This is azimuthal quantum number. This is nothing but, this data is nothing but fine spectrum. Fine spectra. Okay. This azimuthal quantum number values that represents fine spectra. Okay, done. It is principal quantum number that indicates orbit. This signifies orbit. This signifies fine spectra, means azimuthal quantum number, represents subshells. 0, that is S, P, D, F subshells. Okay, fine spectra, right. Now, listen carefully. Zeeman effect means splitting of fine spectral lines, under the influence of magnetic field, This is in magnetic field. Okay, I mean magnetic field, the splitting of fine spectral lines under the influence of magnetic field is called, the spectra obtained in that is called Seimens effect. You got it? Seimens effect. What is that Seimens effect? Once again, splitting of fine spectral lines under the influence of magnetic field is called Seimens effect. The splitting of fine spectral lines under the influence of electric field, under the influence of electric field is called Stark effect. Okay, the results is same, so the field is different. One is magnetic field, the other one is electric field. Okay, the studies are identified by Landis, and that is Seimens scientist, Stark scientist. Okay, they observed the splitting of the spectral lines in different fields, magnetic field, and he observed in electric field. Okay, the data was explained by Landis. To explain this data, he discovered a new quantum number that is called magnetic quantum number. Okay, that is Landis discovered magnetic quantum number to explain splitting of spectral lines under the influence of magnetic field and splitting of spectral lines under the influence of electric field. That is the basic concept of magnetic quantum number. Very good. So after this, magnetic quantum number is given by the symbol m, small m. Okay, is given by the symbol, magnetic quantum number is given by the symbol small m. This m represents orientation. It represents orientation of suborbit. Be careful, it is suborbit. Okay, it is orientation of suborbit. This represents orientation of suborbit. What does it, orientation of suborbit? This result, the orientation value results orbital. It is going to represent orbital. Okay, orbital. Now, so m values, that means the orientation values of suborbit, orientation values of suborbit, that means m values are ranging from, these values are ranging from minus L to plus L including 0. Okay, m represents what? Orientation of suborbit or subshell. That results orbital. Okay, fine. The orientation values are depends upon L values. That is, m values depends upon azimuthal quantum number value, that is L value, right? So L, azimuthal quantum number value, depends upon n values. Okay, principal quantum number that we studied. L is equals to n minus 1. That is azimuthal quantum number values depends upon principal quantum number. Similarly, magnetic quantum number depends upon azimuthal quantum number values. These values are ranging from minus L to plus L including 0. Okay, so total how many orientation values are existed? M has the total orientation values that is equal to 2L plus 1 values. M is equals to 2L plus 1 values. So values, this indicates what? Number of, this represents number of orbitals in a subshell, in a subshell. Okay, you got it? So how many orbitals present in a subshell? That is equals to 2L plus 1. Okay, each one value represents an orbital. Each value, each orientation value indicates an orbital. Okay, see, as we know that P subshell contains 3 p orbitals. Okay, so all the we can exercise under examples. Okay, so m values are ranging from minus L to plus L including 0, and the total number of orientation values are equal to 2L plus 1. That means that represents the number of orbitals in a shell. Okay, is it clear? Next, coming to the last point of this. So it is number of orientation values of a subshell. Remember, m, that is orientation values of subshell. In a subshell, how many orbitals are possible? So that is 2L plus 1 values are possible. Now, number of orbitals exist in a subshell, that is equals to 2l plus 1. Number of orbitals in a shell, maximum number of orbitals, maximum number of orbitals in a shell is equal to n square, is equals to n square. That means, for example, in second orbit 2 square, in fourth orbit 4 square. So maximum number of orbitals in a shell equal to n square, maximum number of orbitals in a subshell equal to 2l plus 1. Should not forget. Okay, this is the brief data about magnetic quantum number. Okay, so magnetic quantum number we have to explain, okay, in different subshells and different shells. Okay, that we'll discuss in the next session.